Have you ever heard someone say something like, the population of China is growing exponentially? Something like that. Well, this is what they're talking about, exponential functions. I'm going to let you read all of this wordy stuff. Let's just skip right down here to these graphs. So, before what we've been working with, I'm a big supernatural fan, so I'm going to say then and now. Alright, so before we were working with algebraic functions, like x to some power is equal to some number. Okay, what we're going to be dealing with now has the variable in the exponent. Okay, that's the difference between what we've been doing and what we're about to do. This is the function of a exponential growth equation. That's because you can see it starts off really low and slow, and then all of a sudden it turns and it just shoots up really fast. That's growth right there because it's increasing as you read left to right. If you look at this one, the exponent is negative. This is called an exponential decay function. So this one starts off really high and it keeps dropping really fast, but then all of a sudden it almost flattens out. Although what's happening is it's getting really close to zero without ever actually touching zero. So just keep in mind the two types of problems. We have this one, which is our exponential growth, where the exponent is positive. We have this one, which is exponential decay, where the exponent is negative. So the general form for an exponential function is here. A is just some number we're multiplying our function by. B is our base, and x is in the exponent, where x is actually our variable. Okay? A is not 0, so that's a condition for A. B is a positive real number, so this has to be positive and real. The domain of this function is all real numbers. We can actually see that from these two graphs. The x's go forever left and forever right, which makes the domain all real numbers. The range of f is all positive real numbers, but that's if a is greater than 0. So if this number is positive, then our range is all positive real numbers. See how we had this one? If this number in front, there's actually a 1 right there. If that number is positive, our range goes from 0 to infinity, but it doesn't include 0. If a happens to be negative, this one here, so if you had something like f of x equals negative 2 to the x, that one would actually have a range of all negative real numbers. We'll do some of those in just a minute. The y-intercept is 0a, so a is right there, and the horizontal asymptote is y equals 0. So we do have a horizontal asymptote right here, which is the equation y equals 0. Your y-intercept is the point 0, 1, which you can see right there. It's the same thing for this next one as well. 0, 1, horizontal asymptote is y equals 0. So let's just look at this first example. Which of the following equations are not exponential functions? Well, this has an x in the exponent, and all of these things are true. So that means this is exponential. How about this one? This one is algebraic because the x is in the base. So this one is not exponential. How about this one? This one has an x in the exponent. And what did we know about b? B just has to be any positive real number. 1/3 is a positive real number, right? So this one is also exponential. And how about this one? This one is not an exponential function. Why not? because b has to be any positive real number. This is what's raised to the exponent. That makes this also not an exponential function.